Okay, hello everyone. And today we're going to be showing off my computer that I've built. It's been a while and I really wanted to show some people. So, I'm going to actually um I'm going to hold on. I want to copy the world. I don't really know how to do that. But we're going to hop into my world. Okay. So yeah, this is it. It's a lot, I know, but yeah, this is it. It's quite a bit, gonna be honest, but it works. And the reason I wanted to copy the world is because I'm messing with some stuff here, but just for you guys, I'm going to actually destroy this. So I'm gonna destroy this for you just because I really was working on some program for this computer to run. Okay, so what I'm actually destroying here is the program memory, which is kind of like just it's like telling the computer what operations to carry out. I see we have two people watching, and one of them's me, so we have one person watching. I wonder who that is. Um, okay. Now let's clear this memory, and we'll do um some adding sequences or something. Let's see here. Okay, 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 yes. Okay, we got this. Okay, I think we got all the program memory off. So, um, okay, so this is it, and I will show you a few things. So currently, actually, we have some numbers in the ALU, but just to tell you that this right here was not my design. Um, past this one point right here, which I'll mark it out. Past this point, I did not make over here. I did not make that. So, yeah, I did not make that. I actually downloaded the schematic for that. But everything else you see, I have made totally from scratch. Like this register here. And I have made this using the help of World Edit. World Edit is a very good mod to use when you're building anything that can be copied and pasted over something. Let me just stop this real quick. Need to stop this process. It's currently trying to do some operations. Okay. 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 Um, so let's do some adding. Comment if what you want me, the two numbers you want me to add. But I'll go ahead and set it up so we can do this. So on the third line of code, we're going to need to read from 1 and then write it. Okay, so here we need to read from 1 and we're going to do the first one, and on the second we're going to do the second one. Okay, so now we should be able to go to the fourth line and do second read here. And we should have everything to add two numbers. Now, the two numbers we add can be all the way up to 255 plus 255. I think. Yeah, and that's a very big number actually. Like, that's pretty big for something like this. But we're going to add, let's do a simple, like, we'll do, and yes, this computer uses binary code, so some of you watching may not understand what the output looks like, but I'll translate it and tell you what it's saying. So, we'll do 18 plus 20. We'll do 18 plus 20. So, 4, 8, 16, and then a 2. So 1, 2. Okay, so that's 18 in binary code. And then we'll do 20, which should look like this and that. So this should carry out the operation for doing that number. And actually for this we're going to need to destroy these. This was for the Fibonacci program I was trying to run. It just repeats the process over, but for this operation we don't need to do that. So we're going to start the process over again. And how we're going to do that is we take this and we destroy that. And then this automatically will just start. So you can see it's already reading from the first line of code. And we can go way over here to our ALU and our answer will come out here. And currently nothing, that's not even the answer because I was trying to add something else earlier. So that's not the answer, but it'll come out soon. Okay, so it's already doing something. Okay, so it looks like our answer's here. Hopefully I didn't mess up any of the code. But if you do 18 plus 20 in your head, it equals 38. So take 32 plus 4, which that equals 36, plus 2, that equals 38. So yeah, it just added those two numbers. So yeah, it can do that. It can multiply. I have got it to multiply before. We actually might do that right now. Let me multiply something like 3 times like 3. We'll do like 3 times 3. So, we're going to do, let's see here. 3 times 3 would equal us to put a 3 here. Oh, I destroyed that on accident. We're going to have to destroy this. and do that. So now that's going to do 3 times 2. And now multiplying is a little bit harder, because once we get the answer, we need to add it again to our current thing. So we're going to have to access this, like, pretty much the whole time. So we'll just... Oh, wait, I think I've... Oh, yeah, this is the wrong line, actually. We do it on this line here. We'll just do it a couple lines just to make sure this stays on. And then we're going to need to take the answer and wrap it back around. And we'll actually do this on this operation. Or we can do it on this one. And we're going to write to, we're going to write to 1. Okay, hold on. Let me see here. Write to 1. Okay, so on the 5th line, we're going to write to 1. And then we're going to read from 1. And for the read on the 6th line of code, we're also going to do that. So this, if I did the code right, this should do it. I don't know completely if it will do it, but this should run the operation. So, to start it up. Okay, let's see here. Okay, so the answer is obviously 9. So, my computer runs at a, at 0.2 hertz, which is a calculation every 5 seconds, which I mean is not bad, but it could be faster. I haven't actually tried to make it any faster, but it definitely could be faster. I just really haven't tried to make it any faster. Okay, something is not doing right, actually. I don't know why that's on. I honestly don't know. I'm gonna restart it and see what happens. I think one of my code lines actually might be wrong. But, I actually might have an idea on what that one was. But we can look at our registers here and see our output. Okay, there's our first problem. 1 is not outputting the right answer. Okay. Yep. One misplaced torch can just ruin the whole process, which is not good. But that just proves how easily this can be ruined by just one misplaced torch. And this actually might not be the whole problem. There might be more problems in this code. I don't know, usually writing code, like, we're writing down to the, like, wire type code. So, okay, so we got the right 3 out. Okay, so 3 should be coming out. And then 3 coming out there. And then, so we should have 6 come out the output. So yeah, we do have 6 coming out. What is that noise? What is that noise? Okay, well, I don't know what that noise was. I think that was something to do with, I don't think that was in Minecraft. I think that was something to do with my computer. I don't know exactly what it was, but this is 8 and this is 1. So it multiplied 3 times 3, which equals 8. Now the problem with multiplying big numbers is I could do big numbers times 3, but times 3 is as high as I can go because I'll run out of program memory. Because one number can go up to 255, but the other number can only go up to like 4 at the max if I extended my program memory. But my problem is that my program memory, I poorly built it. So you can't add on to this lines. It just stops here because this is here. And then this could go on, but you need 2 lines of code to do this. So, yeah, I'll describe a little bit more on what's going on. So, these wires are your write to the memory. All these, which those like write, you can see them going along this bus here. And there's a few of them over here. There's 3 lines. These are your read and writes from the register, which is basically memory. It's just a ALU memory, which it just tells the ALU, which is the adding, I don't know, just the adder pretty much, and it just tells the numbers. It just tells it what numbers to go into ALU. And since you can only read one number out of the registers at a time, so it's not a dual read, it's just one reading, which is it's not very efficient, but it still can get the job done. And the way that I put 2 numbers in through one number system is I have this like little memory thing here. So if I had like 1 coming out into the ALU and I wanted to add 1 plus 1, or no, 1 plus 2, 1 would come out and I would save the 1 to the first input. And then when the 2 came out, it wouldn't affect the first input, but when 2 came out, I'd save it to the next input. And our output would be right out here and also along these buses here, which these buses go through a locking, which means if I want them to pass through here, I can, but if I don't need them, the answer to go anywhere, I will lock it so no answer can get through. But the ALU just kind of goes back into program memory. I mean, not program memory. It goes back into registers. So when we're doing multiplication, basically what happens is 3 and 3 gets stored here. Then they go into the ALU. And the answer, which is 6, goes along here. And then travels down here into the input for the registers. And it's telling the registers that it's going to do is saying, okay, I want 6. It's just feeding 6 into the register, and so you just tell the register to save whatever's coming in into register 1. So now you have a 6 in register 1. And so when you have a 6 in register 1, you just unlock one of these 2. And since we already have 3 going in, we unlock another, we'll have 6. So 3 and 6 equals 9. And that's how it's doing its simple program things. It's just doing it with. And if you know what the Fibonacci program is, I'm trying to run that. It's like an adding sequence. I haven't really got the code for it. But I've been really trying to get the code. But I just destroyed what I was trying to make to show y'all. But yeah. So I just thought I would want to show out my Minecraft computer. It's pretty massive, and I really have enjoyed making it. It's really been a project. So yeah, this is the end of my live stream.